Hello Techies, welcome back to Techie Uday. As usual, today also we are going to solve a Leetcode problem. Specifically today we are going to solve a string manipulation problem. Actually, we do not manipulate the string. We should return whether it is possible to manipulate the string according to the constraints that are given in the problem. Let's look into that. What is the problem and how we can solve that. This is the problem. Check if a parenthesis string can be valid. So the problem is we will be given a input string, that is yes, a locked string. Both has same length. If this has 5 length, then this will be also 5. Here this is 6 length, so locked is also 6th length. So yes is the input string that we have to manipulate. What is the locked? Locked indicates at a particular index of yes, we can manipulate it or not. If it is 0, then we can change the parenthesis. If it is left, we can change it to right, or if it is right, we can change it to left, and we can do that in any number of times. There is no constraint or restriction that you have to change or you have to modify a particular index of yes these many times. So we can do as many times that it is required. So that is the problem. Finally, if it is possible to return or if it is possible to modify the string yes such that it is forming the equal or valid parenthesis. If we see in the problem, it should form the valid parenthesis. Let's understand this problem through visualizer better. This is our visualizer, Techie Uday's algorithm visualizer. Here we can visualize the problem. If you can see the screen here, this is the input that they have given. This is the input S and this is the locked string. So the input S is represented here, the locked string is represented here. The locked string can have only zeros or ones. If it is 1, it indicates that it is locked, so you cannot modify this index of yes. So in the result, it is grayed out. These two areas are grayed out. So we can modify only these areas where it is locked is 0. So we need to modify the string so that it forms a valid parenthesis. Now it is open, it is closed, it is open, it is closed, and it is open, it is closed. Now it forms a valid parenthesis, right? So we need to return true in this case. If it is not possible, for example, a open parenthesis and here it is not locked, then even though you have an open parenthesis and it is not locked, you cannot make this valid parenthesis because it has odd number of parentheses. Even though you modify any parenthesis, one parenthesis will be unbalanced in any case. So you cannot modify, you cannot make it valid even though whatever the operation that you perform on this input. Similarly, if we have an even number of parentheses, even pairs, but let's think it is the closed one here, it is closed one here and the position is locked. So what happened in that case? The position got locked, so you cannot alter this one. So whatever the operations that you perform on the remaining things, we cannot change, so it is always false. A string, a valid parenthesis cannot end with an open parenthesis, right? This should be unlocked to make this parenthesis as valid. So since it is locked, it is false that you cannot make this string valid whatever the number of operations that you perform on the remaining unlocked variables. So this is what the problem is. So what is the approach and how we can solve this problem? Let's look into that. So we can solve this problem using two methods. One is two pass array. We'll traverse the given string from left to right in one pass and from right to left in another pass. Then we'll validate the string is valid or not. How it works? When we traverse from left to right, we will consider all unlocked strings as open parentheses. whenever we encounter a open parenthesis or an unlocked string, we will consider it as open and we will increment open by 1. Whenever we consider locked string and also it is closed one, we will decrement the open count. If the locked string is also open one, then we will increment the open count. So finally, the open count should not become less than 0, because if the open count becomes less than 0, it indicates that the string doesn't have enough number of open parentheses even though we are considering the unlocked parenthesis as open. It has so many closed parentheses so that we cannot make, it has so many locked closed parentheses so that we cannot make the string valid with any number of operations, because it has locked closed parentheses more than locked open parentheses or unlocked parentheses. So we cannot make the string valid if the open count in any case becomes 0. And the same way, from right to left, we consider every unlocked index of the string S as closed. In that case, if the closed becomes 0, it indicates that the string has more open parentheses than closed parentheses, so we cannot make the string as valid. We need to consider only the open count or closed count becomes less than 0. It will be greater than 0 always, and it should be greater than 0 always, because we are considering our unlocked strings are also open in left to right pass, closed in right to left pass. Let's see that in action. This is the solution that we are going to see. Here we have variable n and taken yes, and if it is odd, we cannot make the string as valid because it has odd number of parentheses. To make the parentheses valid, the parent should be in pairs. We cannot make it valid, so we are returning false. Here we have taken one variable open and initialized with 0, and we started traversing the string from left to right. So in each case, when the locked character is 0, it means it indicates that it is unlocked character. We can change the value. So we consider it as the open parenthesis from left to right pass, and we'll increment the open count by 1. So we process this index 0, and since it is not locked, we'll consider that as open parenthesis and we'll increment open by 1. In this index, it is locked and it is closed parenthesis. We cannot make it as open parenthesis, so in this case we'll make the open count again 0. In the next, it is unlocked, also it is open. So no matter it is open or closed, when it is unlocked, we consider it as open and we'll increment the open by 1. Here it is locked and closed, so decrement it by 1 and it becomes 0. Here it is locked and it is closed, even though it is closed or open. In the left to right pass, consider it as open and increment it by 1. Here it is locked but it is open parenthesis, so we need to increment by 2. So in the left to right pass, open never become minus, so we are not returning false. We go with right to left pass now. In the right to left pass, we will initialize a variable close equal to 0 and we start traversing from right to left. So we'll start with last index is n minus 1. This is nothing but n minus 1. Here it is closed. So if we process this, then what happens? Let's see, that becomes minus 1, which should not be there. Close cannot be less than 0. So the program terminates and we should return false because we cannot have open closed parentheses at the end. So let's think we have a case like this, even though it is like this and we are not locking it. Let's consider this example which is given in our program. So start with left to right pass and see how it goes. This is the same code that we have and we initialized the open count to 0. Now we start with processing left to right. Now we process open count initially 0. So we process this one and we make it as 1, and we process this one, that will become 0, and we process this one. Here open again increments to 1 because we are incrementing when it is not locked, and since it is locked and it is closed, we decrement the open by 1 and becomes 0 again. Since it is unlocked, even though it is closed, we make it as open and we consider it as open and we increment it by 1. Here in this case, even though it is closed, we consider it as open because here it is not locked. So we consider it as open and we'll increment the count to 2. Since it never becomes less than 0, it is not false, and the open count left to right pass got succeeded, and we move on to right to left pass. In this right to left pass, we start with the last index, and if it is closed one, then we'll increment close by 1. If it is open and it is not locked, we can make it as closed and increment the close count by 1. So here in this case, it is not locked. So we can make it as closed and then we increment close count by 1. Here it is open but it is not locked. So we can make it as closed and we can increment the close count by 1. Here it is already closed, so we'll increment the close count by 1. It is open, make it as closed and increment the count by 1. It is closed, so increment the count by 1. It is open, then make it close, increment the close by 1. Since the close never becomes 0, we are successfully completed and the string is valid. This is how we can solve this problem in a 2-pass approach. There is one more efficient approach but a little tricky approach that we'll look into now. This how you understand this approach. If you have any doubts, comment down below. I'll explain you much more detail. If you want me to explain any other problem or any other concept, comment down below. I'll make a separate and detailed video on those problems or concepts for you. If you like the video, hit that like button right now and subscribe to the channel for more interesting content. Now we'll see the other approach of this problem, which is a single pass approach, and how we can solve this one go. Instead of traversing the array 2 times, how can we solve this problem with one traversal? Let's look into that. Now we are going to look at this problem a different approach. In a single pass, how can we solve the problem? Let us assume 2 conditions. One is the worst condition and one is the best case. The worst case is the maximum number of unbalanced parentheses that a string can have. And the best case is the minimum number of unbalanced parentheses that a string can have. The maximum number of unbalanced parentheses become less than 0, then we'll consider the string as invalid. If the minimum number of unbalanced parentheses becomes less than 0, it becomes -1, we'll mark it up to 0 because we are assuming that is a minimum number. It cannot be less than 0. We'll mark it up to 0. How this works, I'll explain you in detail while we see the solution. Let's see that. Here we'll approach this problem in a tricky way. In this approach, we'll take 2 variables, minimum and maximum. Minimum indicates the minimum number of unbalanced parentheses. Max indicates the maximum number of unbalanced parentheses. So when a string is locked and if it is open means it is unbalanced. It needs one more to get it balanced, right? So we consider it as the worst case scenario and we'll increment minimum by 1 because it is unbalanced, it needs one more, and also the maximum will be incremented by 1 because we need another parenthesis to balance. If it is open, we'll increment both unbalances like minimum and maximum by 1. If it is closed, we'll decrement both unbalances by 1. So here we are doing that, right? Let's see, approaching index 0, we'll increment max by 1 and decrement minimum by 1. So it is considered as best case for both. If it is open parenthesis, then it indicates that it is an unbalanced. So we are incrementing max by 1. If it is closed parenthesis, it indicates balance. So the minimum unbalances should be decrement by 1. So we consider it as both open and closed. So we'll increment max by 1 and we'll decrement min by 1. Right. So while considering this, we'll decrement min to -1 and we'll make max to 1. Since minimum is -1, it should not be -1. We'll make minimum to 0 again, because we are considering it as minimum number of unbalanced parentheses, like minimum number of opens. Since it is -1, we can balance it by making it to 0. If the max become less than 0, it indicates that we cannot make the string valid because it has too many unbalanced parentheses. The only case we are decrementing the max here is here. Whenever there is a closed parenthesis, we are decrementing the max. So still it becomes -1. It indicates that it has more locked closed parentheses, which makes it is impossible to make the string valid. The only case where we are decrementing the minimum is when it is locked unclosed. So it indicates it is balancing the unbalanced. We are decrementing it by 1. The only case we are decrementing the max is it is locked, so we cannot change it, and also it is closed. If the max becomes -1, it indicates it has more locked closed parentheses, so we cannot alter the change. It has more locked closed parentheses than it is required. So in that case, if the max becomes -1, we'll return false, indicating that we cannot make the string valid. If the minimum becomes -1, the minimum indicates that balancing. So if it is becoming less, it becoming balancing. Minimum indicates the best case that we are considering for balancing. So when it is closed, we are decrementing the minimum. Also, when it is not locked, we are decrementing the minimum. Locked has a flexibility that you can change it to open or closed parentheses. In this case, we are incrementing the max, but still it is becoming -1. It indicates it is not valid. Here we are incrementing. In the flexible area, we are decrementing the -1. In the flexible area, we are decrementing the -1. It can become -1. So we'll mark up it to 0 when it falls below 0. So this is the case here. This is locked and this is closed. Locked and closed. So we will decrement both min and max by 1. So minimum has become -1, max has become 0. Since minimum cannot be -1, we will mark it back to 0. Similarly, second case, it is not locked. So there is a flexibility. So what we are doing, we'll consider it as best for both. We'll increment max by 1 and decrement min by 1. So since it cannot be -1, we'll mark that back to 0. Right. Now consider this case. In this case, decrementing -1 and incrementing 0, and it cannot be -1, so we'll increment and make it back to 0. And then this case, this is closed, so unlocked, so we decrement both max and min by -1. Since -1 cannot be, we will consider it as 0. And then we consider this one. Here, min becomes -1, max becomes 2, and min becomes 0, we will make it as 0. Since it cannot be -1, we will make it as 0. And then in the last one, min becomes -1 and max becomes 3. Since min cannot be -1, we'll mark it as 0. And finally, since min is equal to 0, we can return true, that is a valid scenario. We'll return the result as true. This is how we can solve this problem. I think it is a little complicated approach to understand. Listen to the video 2-3 times, you'll get to know. If you still have doubts, comment down below. I will explain you in much more detail. If it requires, I'll make another video on this to explain in more detail. Thank you for watching this video. Have a good day.